Okay, for number 7, it says classify the numbers in the box as perfect squares and perfect cubes. To classify a number, put it in the appropriate column. Numbers that are neither are not placed in the chart. So our first thing we're going to do here is we're going to decide if each of these numbers is a perfect square, is it a perfect cube? Now this is 44, and I think it might be 4th period we changed that to 49. One of the classes we changed that to 49. So keep that in mind. Okay, so for the number 1, we're trying to decide, is this a perfect cube, a perfect square? Well, 1 times 1 equals 1, so it's a square. 1 times 1 times 1 equals 1. So 1 is both a perfect square and a perfect cube. 16. 4 times 4 equals 4 squared, or 16. And there's no cube root for 16. Just in case you want to see how I figure that out. 4 times 4 is 16. 2 times 2 is 4. 2 times 2 is 4. If I want to see if it's a cube root, I need to have 3 numbers multiplied by itself. Here I've got 4 2's multiplied by themselves. If I group them, I have 2 2's multiplied by themselves. So I cannot get any groups of 3, or I can't get 3 groups of anything. So 16 is a perfect square, not a perfect cube. 27 is 3 times 3 times 3. It's 3 cubed. So 27 is a perfect cube, but not a perfect square. It's definitely not a perfect square. If I were to break this down, I get 3, 3, and 3. That's 3 groups of 3. 3 times 3 times 3 is a cube. I don't have any groups of 2 I can create there. So if we do 44, it's it's an either. So we would leave it out. If you are the class that I did 49 with, 49 is 7 times 7. So you would put 49 in the perfect square column. Again, that was just one class that we did that with. If that was not your class, ignore that part. 64. 4 times 4 times 4 equals 64. 8 times 8 equals 64. So 64 is a perfect square and a perfect cube. If you're unsure about how I got the 64, I believe on one of the examples on the cube root video, I do 64. 200 is going to be neither. Okay, and if we want to take a look at how that works, we make some room here. If I look at 200 and I break it down to factors, I get 25 times 4, so I get 5 times 5 times 2 times 2 times 2. And what we would be looking for is we're looking to group sets of numbers. If I can get 2 groups of the same numbers, then I know it's a perfect square. If I can get 3 groups of the same number, I know it's a perfect cube. So if you look here, I have a 5 and a 2, and a 5 and a 2. So that's 2 groups of 5 times 2. The only thing is I have this little 2 left over. If there was another times 5 out here, then it would be 10 to the 3rd power, because I'd have 5 times 2 times 5 times 2 times 5 times 2. But that's not what's happening here. Okay? I have this little 2 left over, so it's not perfect. Now, if I were to make this 100, see how if it's 100, when I break down the 100, I get 5 times 2, 5 times 2. That gives me 10 times 10. So again, when we're factoring, we're looking to group like numbers together, or get groups of numbers together, matching groups, 5 times 2, 5 times 2. And if I can get, if I can get equal groups, then I know it's a perfect square or a perfect cube. So that's why 200 is neither. Okay, so 200 is neither. And then 225, if I break 225 down, let me move it up a little bit. 225 is going to be 5 times, let's see, 5 times 45 45 is 5 times 9. 9 is 3 times 3. So I end up with 5 times 5 times 3 times 3. Now if I rearrange this, this might help you see the groups a little bit better. I get 5 times 3 times 5 times 3. Okay, I didn't add or take away any numbers, I just rearranged, because what I want you to see is here's one group of matching numbers and a second group of matching numbers. Since I have two 5 times 3's multiplied by themselves, it ends up being 15 times 15, which is 15 squared, which means 225 is a perfect square, not a perfect cube. That's it.